find out the modulus of rigidity. The main aim of this experiment is to find out the modulus of rigidity of a given material. Now this material is given here. Now I am going to find out the modulus of rigidity. When do we get the question of modulus of rigidity? When the shear forces are existing, when they are coming into picture, then only we go for the modulus of rigidity for designing the materials based on the type of loading. Here the type of loading, if it is creating the shearing of the material, then we design according to the modulus of rigidity of the material. Now, so this is the setup here. It's a torsion testing machine. In this machine, we are going to fix this in between these two chucks. You are having two jars here. Now, then slowly we will switch on this one. When we switch it on, it will start twisting this material, and we will find out always. Also, we will find the readings of torque and the angle of twist. You know the famous equation, T by J is equals to Fs by R is equals to Z theta by L. T by J is equals to Fs by R equals to Z theta by L. In that, so here by using this equation, we are going to find out G. What is this G? Here G is modulus of rigidity. In different textbooks, you will find different letter for this one. It can be G, C, or N. Now here T is a torque, J is a polar moment of inertia, Fs is the shear stress, this is the equivalent radius, modulus of rigidity, theta is the angle of twist, L is the length of the given torque. Now according to the standards for this machine, here the specimen is, here it should have a dumbbell shape, outside here it should be, the outside diameter should be the 10 mm according to the figure shown here, and actual diameter of the specimen is 8 mm. Diameter is 8 mm. And 31.5 will be fixed inside the jars. That is the provision given for the chucks. Now we will, first of all we will learn, before we start the machine, we will learn how to, fix the test sample according to the standards inside the chucks. Now here, see here, we are having the jars here. Can you see the jars? Here inside. So if it is not vertical, you should align it. You should bring it to a vertical position by using this. So you can rotate this one. It is manually thing, that is what will happen. You got the vertical position. Now you just fix it. It will not go beyond certain length. That length is a standard length, 31.5. The length of this test face is 143 mm. So according to standards, it will fix the testing length. Automatically it will fix. Close it. You can use this lever for closing. Fixed. Now before we rotate this one important precaution here. So you need to release this. there must be some gap between these two, at least 1 centimeter, that is 10 mm gap should be there. Just move this. So we got aligned here. Now just close it. Use the lever. In a position, you just tighten it. It is done. Now the test piece got fixed between the two checks. For keen observation purpose, we can use a chart as a marker. We can find the twisting of the given piece. Now the setup is ready for the testing. See, the machine will read the torque. There are some transducers, some sensors are here, which is used to find the torque directly. So you can find the torque as well as, you can measure torque as well as angle of twist. That is theta, angle of twist. Just press enter key to start the test. Enter, torque and angle. So you just make it to 0 initially. Okay, now I can use this button, then because this one is already set. Now I am going to start the experiment now. So you need to take the readings of for how much torque, what is the angle of twist, or you can take vice versa for how many degrees of twist. Here we get in degrees, here it is given in degrees, and the torque is in Newton meter. So for how, say 360 degrees or 60 degrees of rotation or the angle of twist, what is the torque? For what torque, how the twisting is taking place. So that can be taken here. Started. Be careful. See, you have a rotating part here. If you are having ID cards or any other things, see that it is away from this one. Otherwise, it will get such that no accidents take place. See, the twisting is taking place. You can observe the marking. It is the horizontal line converted to the helical in direction now due to twisting. So meanwhile, you should go for taking the readings you can take the readings here, torque and the angle of twist. Automatically the machine will switch off at the breakage point, fracture point. So what is happening meanwhile? It is storing, the system is storing the strain energy. It is getting deformed. It has completed almost 2.5 twists are over. 360 plus 360. It is about to reach the 3 twists. The specimen break. Do you want to continue? Then press enter. Now I want to remove the material because the system has broken. How it got broken? Now we will see. Just push it back. The system got broken. Now you can remove the test piece, and the readings were already taken. Torque and the angle of twist was already taken. By using the equation, you can find out what is the modulus of rigidity. Radius is known, that is 8 equivalent radius is 4 mm. Shear stress can be determined. Length is known already. Length is 80 mm. Diameter is 8 mm. Length is 80 mm. So by using the known values, you can substitute there and you can find out what is T. And polar moment of inertia is also known. The formulas pi by 32 d power 4. So by using these formulas, you can calculate. So that's the calculation part. You can find out what is modulus of rigidity. Now I will tell you how to remove the piece. Release this one always in that position. Now open, hold it, open it. Next one, this is inside. So you cannot pull it like this. So you need to release these two jars. The method here it is. The place where you don't have the threads, so there you keep this with the support and hold it. So you can release the piece.